Hello, Algebra 2 students. This is Mrs. Banyan, and today we're going to be graphing rational functions, but we have to use some synthetic division in these problems. Let's start with a review. List the transformations of the following function. If I have a negative on the outside, then that's a reflection over the x-axis. When I multiply by 2, that's a vertical stretch by 2. If it says x minus 1, then that is a shift right 1. And if I'm adding 3 on the outside, that's shift up 3. Now that we've listed the transformations, we could graph this using transformations. Let's take a look at this problem. What do you notice? The first thing that I notice is that I have an x on the top and the bottom, and we've never seen that before. See, this equation is in the wrong form. We cannot graph this one using transformations. So we're going to have to rearrange this information, and we're going to use synthetic division to do that. So let's write our equation again, and we're going to use synthetic division to rearrange this information. If you look here, I'm dividing by x minus 1. And since this is x minus 1, it's written as a factor. And we know that when it's with our x's, then it's the opposite. So I'm going to put a positive 1 in the box. Then I list my coefficients. I only have 2. It's a 3 and a negative 5. And I'm ready to do synthetic division. First thing I do is I bring down the 3. And then I'm going to multiply 3 times 1. And that's 3. And then I add straight down. Negative 5 plus 3 is negative 2. So negative 2 is my remainder. A remainder is always part of what's left over. It's essentially a leftover. It's the part of the whole. And when we have something that's a part in math, we write that as a fraction. A fraction is part of the whole. So negative 2 is going to be written as a fraction, negative 2 over x minus 1, because that's what we were dividing by. And I still have this 3 out front, and it's a whole number. So I'm just going to write plus 3, but I'm going to put it in the back, because that's usually where we see it. So this is how we rearrange this equation using synthetic division. Now that it's rearranged, we can graph this using transformations. When graphing the function using transformations, we always start with our parent points, and these are the parent points for 1 over x. Notice that this line right here, it's crossing out these points here because I cannot plug into 0. So I have a vertical asymptote at 0, and I'm not getting out any zeros, so that's a horizontal asymptote at 0. As my function moves, remember that my asymptotes will also move. If it says x minus 1, then I know that my x rule will be x plus 1. For my y rule, I have a negative 2 and a plus 3, so it would be negative 2y plus 3. Now let's add 1 to all of our x values. For our y values, we're going to multiply by negative 2 and then add 3. And notice that my asymptotes moved along with my function. This has a shift to the right 1 and a shift up 3. So if I have a shift right 1, then that means that I have a vertical asymptote at 1. And if I have a shift right 3, then I have a horizontal asymptote at 3. Then I can graph my points around it and connect my dots with my lines. Remember that as my function gets bigger, it's going to get closer and closer to those asymptotes. And those asymptotes, again, we're at 1 and 3. All right, now you guys are going to go ahead and watch another video that has to do with just more practicing the synthetic division to rearrange your equations. Thanks so much. Bye.